Okay, gents, here's the last question inside the long questions inside section B. A fuel expert has calculated the rate of increase in oil consumption in a given country is dN dt, where n is the number of billions of barrels of oil used up after t years. What are they giving you? They're giving you dN dt. They're giving you the rate. Okay, they're giving you the rate. That's given. It's not saying that n is this thing or the barrels or this thing or anything like that. It's just saying what is the rate at any one particular time. If you want to go back to n equals, where n is the number of billions of barrels of oil used up, what would you do? So if you have dy dx and you want to just go back to y, you're going to have to integrate. So it looks to me like this is almost certainly going to be some type of integration question. Okay, it says find the rate of consumption after 10 years, after 20 years to two decimal place in, so they're asking for the rate itself, so there's no need to do anything wild here. They're just saying t is 10 and t is 20. So we can just fill this in 0.8 and it's e to the power of 0.006 by t, where t is 10. Okay, so 10 years, the rate is 0. Now it says two decimal places, 0.85 is the rate. Okay, t equals 10 years and t equals 20 years. What does that actually mean? That means that at that exact moment, as you move over 1, as it's an instantaneous rate, okay? But at that exact moment, when you move over 1, it's going up by 0.85. That is what you're looking at. T equals 20 years. So we go back up. We can just change that. So we get 0.90. Okay. That's what we get. That's in billions. So I don't, excuse me, I don't know if they want us to say, it's no harm saying that. I'm saying 900 million, 0.9 of a billion, 900 million. We should probably throw on 3 extra zeros there. Okay. Hi gents, we're going to have a look now at some context and applications. This is again excellent sample. Okay, that was horrific. I was just trying to export a video and it started up again. Okay, show that n is that. So we've already said if we have dn dt, and we want to get n, we're going to have to integrate it. Okay, so we're going to have to integrate 0.8. Just get rid of that, 0.8 e to the 0.006t. So it's 0.8 e to the 0.006t. So this is what n will be. Okay, so we're going to have to actually integrate this thing here. 0.8. So let's work out what this thing is. Whenever you have an integration of e, so like e to the 2t, we'll say, what you should write down is you should write down e to the 2t again, and it's 1 over that thing differentiated. Okay, so in this case it's a half that. So what do we have here? We have e to the 0.006t. You write that immediately back down again, and then you divide by, or you multiply by 1 over this thing differentiated. That thing differentiated is 0.006. Okay, so it's that. Don't forget the plus c. Actually, it is important, and you will lose marks if you don't use it. So let's actually go and use that. So it's that amount plus c. Okay. This thing is nicely going to divide in there. When it divides in there, we're going to get 400 over 3. And we have e to the 0.006t. Even though c is going to come out as 0, it's not good enough just to let that thing slide, okay? In fact, maybe it's not going to come out as 0. Because we can work out what c is by saying that when time is 0, when no time is passed, how many barrels are used up? Well, the number of barrels will be 0. So that's a trick that we often use. So we'll just do it up here. So we can say that n is 0 when t is 0. So we get 400 over 3. We're going to get e to the power of 0, which is just 1. So it's just going to be plus c here, and we get that c is equal to minus 400 over 3. So that is what we've actually ended up with. Oh yeah, and they had given us the answer, so we would have figured it out handily enough if we had made a mistake. So c is going to be minus 400 over 3, and you can see here that you can factorize out 400 over 3. You get e to the 0.006t minus 1. So there you go. That bit on c is very important. Don't leave that out. I know people have in the past. It's time to stop doing that. And also, of course, read the question. Hence, find the total number of barrels used up after 20 years. So what are we just going to do? We're just going to say when t is 20, what's that going to give us? So hang tight and we'll do that. 400 over 3 multiplied by e to the power of 0.006 times 20 minus 1. Close our bracket. So after 20, did it 1 to the nearest anything to the nearest billion? It is 17 billion. Let me just make sure, what have I said there? This thing here is 17 million. Don't forget to throw on billion. Did I actually do that on the first one? Yeah, that was fine because it was 0.85 billion, so not quite a billion. So that is what you are looking at to the nearest billion. Okay, and those are barrels of oil used up. If the oil reserves of a country are 5.5 billion barrels, after how many years will they run out? Okay, so if they run out, they're going to have used up 5.5. So it's n equals 5.5, and it's asking us what's t. So we get 5.5 is equal to 400 over 3 times e to the 0.006t minus 1. So we get 5.5, we'll multiply it by 3, then we'll divide by 400, and we get 33 over 800. And that's equal to e to the 0.006t minus 1. I would be adding 1 to both sides, so you can definitely make your life easier. So that's going to be 833 presumably over 800 is equal to e to the 0.006t. Okay, we'll do ln. ln 833 over 800 is equal to ln e to the 0.006t. So this thing will just turn into 0.006t by our laws of logs. And this is ln 833 over 800. And to get t, we divide both sides by 0.006. So let's do that. So I needed to add 1 to that, and we go ln of our answer and divided by 0.006, and we end up that it is equal to 6 point to the nearest, how many years will it run out to the nearest number of years? So that would be 6.6 7 is what it's saying here, so that's 7 years. That seems a little bit suspect. That seems a little bit suspect. Let me just double check here that I haven't done anything crazy. N is the number of billions of barrels up to after T years. Okay, so N is equal to 5.5. I agree with that. How many years will it run out? Just make sure that I haven't missed 006 T minus 1. Yeah, that seems pretty reasonable to me. 006 T 006. Yeah, so look, I'll just run through the numbers again. 5.5 multiplied by 3 divided by 400 is equal to that. That's fine. Add 1 to both sides. We're also doing fine. Then we should get ln of our answer. And I'm going to take that whole thing, ln of our answer, and divide it by 0.006. And yeah, that's what I'm getting. Well, that's bad news. If you've only got 5.5 billion barrels, it'll be used up in 7 years. It makes you think it's not worth taking it out. I think that might be the point of this exercise. Okay, Venezuela has reserves of 4.714 times 10 to the 10 meters cubed of oil. And if 1 barrel is that, how many billion barrels do we have going on? Okay, so I always find it's a good idea just to write this out. 1 barrel is equal to 0.159 meters cubed. If we have 4.714 times 10 to the 10 meters cubed, what we're saying is each barrel is that. So how many of those things are in there? And that'll be how many barrels we're dealing with. So we have to type this monstrosity in. 4.714 times 10 to the power of 10. We can divide it by 0.159. And it's equal to 2.96 blah blah blah. Maybe actually we need the blah blah blah. 779874 times 10 to the 11. So let's see. When you multiply by 10 to the 11, you got to move the decimal place 11 places. So that would be moving at 1, for instance. So we moved it 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually can't tell the rest. 10, 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, so it's this precise number. Now let's write it in billions. So this is our million portion, and this is our billion portion. So to 1 decimal place, it is 296.5 billion. Okay, how many billions? Maybe we should write in BN or something like that, just to make it clear. So this is how many billion barrels we have. Okay, according to our formula, how many years are they going to run out? So that's going to be n equals that number. So we have 296.5 is equal to this e to the 0.006 t minus 1. So 296.5 multiplied by 3 divided by 400 is equal to 2.22375. Is equal to e to the 0.006 t minus 1. Add 1 to both sides. I'm only doing that to know what I need to do for ln. So ln of this new number, 3.22375, is equal to ln e to the 0.006 t. You know what's happening next. 0.006t by lne, which is just 1. And we have ln 3.22375. Divide both sides by 0.006. Okay. ln of the answer is that, divided by 0.006. And we have that it is going to happen in 195 years. That's all we got. Okay, does that make sense compared to our previous one? I'll just do a quick little double check, make sure I haven't done anything stupid here. 296.5 multiplied by 3 divided by 400 is equal to that. Add 1 to it. Yep, and ln of your answer is equal to that, and divided by 0.006. Yeah, 195. So that's what t is. Okay, so it's going to run out in 195 years in Venezuela. Any more questions on that? No. Okay, that's that one. That was a relatively short one for question 9, and one that you should be hoping to score well. Okay, thanks, gents. Best of luck.